In this quantum mechanics interpretation, we suggest that each excited electron prior to releasing a photon is responsible for erecting a predating path for that photon to surf when it gets released, and that those predating possible paths are what interfere together and are also what can be entangled. The first experiment we will show is an experiment that would prove that the path of the photon predates it and causes the interference before its arrival. In this experiment, we get two sets of possible paths to interfere with each other, but have one set take a longer route before reaching the interference point. We then release a flash of light, or a discrete packet of photons. And when this flash of light reaches the beam splitter, half of the photons should take the longer route and the other half should take the shorter one. And if we then have a very high-speed camera recording what appears on the screen, theoretically we should see two flashes of light appear at different times on the screen. The first one due to the photons that took the shorter route, and the second due to the longer route. Now the big question is, will we see an interference pattern appear on the screen? And will it appear in both flashes, or in just one of them, or in none? Our interpretation predicts that an interference pattern should appear in the first flash only. And this would be due to the predating paths of the long route photons interfering with the predating paths of the short route photons. For the second flash appearing, there would be no interference because the first flash would have already arrived, and therefore its preceding or predating paths no longer exist to cause any interference. And by this, we would have also shown that the interference pattern happens before the photon's arrival, or in another sense, happens faster than the speed of light. The second experiment is a modification on the first one, and it would be to prove that faster than light speed communication is possible. Now that we have shown that the interference happens before the photon's arrival, or faster than the speed of light, in this experiment we try to see if we can alter that interference from a distance prior to the photon's arrival to show that this alteration can be used as a modulation for faster than light speed communication. We do this by placing two polarizing lenses on both routes. And by changing the polarization of just the long route path, causing a change in the interference pattern of the first flash. And since we know that the first flash occurred due to the short route photons arriving first, then we come to the conclusion that this change in the interference pattern happened faster than the speed of light because the photons of the short route traveled a shorter distance to the screen and yet got affected by something further away from the screen, which is the polarizing lens on the long route. And by that, we would have shown that it is technically possible to send a message faster than the speed of light. For the third experiment, we would attempt to actually send a message faster than the speed of light. And similarly, this experiment is also a modification on the previous one. In this experiment, we replace the beam source with two separate sources, where each source gets to be responsible for one of the routes. For the short route source, we would have it so that it is releasing a continuous flood of photons as any typical laser source would. But for the long route beam source, we would attenuate it in a way so that it is releasing only one photon at a time. And because in this interpretation we theorize that a single photon does not interfere with itself should it go through a double slit, but rather its path interferes with the predating possible paths of other excited electrons in the source. Then so long as we keep current flowing in that source, keeping all electrons excited while releasing one photon at a time, we would know that there are many paths erect alongside that single photon's path. And because those paths are due to the excited electrons and are technically still attached to the source, and that we know that those paths are actually what will be interfering with the paths of the continuous photons on the short route, then we can come to the conclusion that any signaling we make using the polarizing lens on the long route is affecting the continuous flow of photons on the short route instantaneously, and therefore we are signaling a message faster than the speed of light. And by this we would confirm that if there is any extraterrestrial communication happening, it must be happening by exploiting this. So just imagine being able to step into an alien world instantaneously in virtual reality. Of course, many would argue that this is impossible because based on special relativity, the speed of light is the speed of causality. It is the speed limit of the universe and it cannot be ever surpassed. But what if we were to show that this is an incorrect notion through our fourth experiment? An experiment that would show that the speed of light is not an invariant speed limit. You see, special relativity explains the consistency of the speed of light in all reference frames through a contraction or an expansion in the passing of time itself. But what if we were to instead explain it through the contraction and expansion of the predating possible path? Because now that we know that each photon has a predating possible path that reaches its target before it does, and because we can realize from the delayed choice quantum eraser experiment that this path can be retro-affected in terms of polarization, then what is to say that the path of the photon cannot also be retro-affected in terms of frequency based on the motion of its target or destination? You see, if you shoot a photon at a moving target, the path of that photon theoretically reaches the target first. And because of that, we will also continue to theorize that the path could then contract or expand based on the motion of that target. And if this does happen, it would lead to a change in the frequency of the possible path, making the photon serve through the same number of frequency cycles but at a compressed or expanded rate depending on the object's motion. But ultimately and more importantly, it would also cause the photon to arrive to that object at the same time, irrespective of its motion. Which means that the photon would always seem to arrive at the same speed for any reference frame. So if it initially started at the speed of light, it would relatively arrive in any reference frame at the speed of light just as long as that reference frame is in its direct pathway. So for our fourth experiment, to test this, we would use electrons instead of photons, because we can get electrons to move at a much slower rate than that of photons through their predating path, when they move due to an electrical potential difference. So all we will need to do is to shoot electrons at a detector that can be still or in motion, and then measure the time it takes for the electrons to reach it when it's moving and when it's still. The first iterations would be to fire the electrons at the detector while it's completely still, and then measuring the time it takes for the electrons to reach it every time. As for the second and third iterations, we would be firing the electrons at the detector but while it's moving. Once while it's moving towards the electron source and the other time while it's moving away from the electron source. And similarly, we measure the time it takes for the electrons to reach the detector each time. And theoretically, in all 3 iterations, the electrons should arrive at the same exact time, with only the difference of having arrived Doppler shifted based on the detector's motion. And this would be the ultimate proof of the physical existence of the predating path. But more importantly, it would also show that the speed of light is no more than actually the speed of the initial photon release. And now we can also start to finally link quantum mechanics with special and general relativity, where the physical effects that were once accredited to time dilation can now be accredited to the transformations of the predating path instead. Thank you for watching, and check the description for the next video.